What's up guys, Jayztwocents here, and we're gonna talk about a 22-year-old game, a game that came out and I was playing it when I was a sophomore in high school. Wow, I really just aged myself. We're gonna talk about Quake II because you guys may have heard the rumors, you may have seen some of the demos, and with GDC going on, NVIDIA has finally launched the fully ray-traced Quake II RTX demo. And it's actually free, you guys can try it yourself. With its unique radiator-mounted pump, premium sleeve tubing, infinity mirror RGB block, and CAM software control, the Kraken M22 all-in-one liquid cooler from NZXT is the perfect choice for small form factor liquid cooling. To learn more, click the link in the description below. Now I can hear some of the grumbling already, like, what's it matter? They had to go back 22 years to find a game that could do ray tracing, ugh. Putting any of that sort of argument aside and just looking at this from a technological standpoint, this is pretty damn impressive. We're not going to go into too much depth on games then versus games today and what ray tracing is and all that sort of stuff. We've talked about it in the past, but high level, what rasterization basically does is it says that we've got a point of light and we've got an object here, and here's the texture of this object, and this light should be shining on this, reflecting this silver surface, and then, you know, putting a shadow here. So it's very, very algorithmic in that everything is already pretty much determined and placed, and then everything else is just kind of faked. Where ray tracing actually says we have a point of light here, light rays are bouncing, and the light ray reflection is handling everything. It's bouncing around, it's saying this object is this texture and the scatter should be like this and it's gonna go off this way. And so the difference in RTX on Quake II is the fact that there is no rasterization. It is all being handled entirely via ray tracing. So the fact that we had to go back that far to get any sort of title that can be fully ray traced, yeah, it's because of polygon count and all that sort of stuff, but it kind of shows where the future of ray tracing can go when the horsepower sort of catches up. Now we're gonna be using a 2080 Ti for this demo because we're using my Corsair 1. My test bench is still at the other studio, which should eventually make its way here. So we're not gonna be testing it with any other lower end cards like, say, a 2060, and yeah, I know some people are gonna be like, 2060 is not low end, but it is in terms of the RTX lineup, it's the lowest card you can get for desktop. The other thing too is that I can't test it with Pascal and stuff for the same reasons that I just mentioned. I'm not even 100% positive if you can run this demo on a non-RTX card, given the fact that this is 100% ray traced. If you could, then it definitely shows how far we've come. So if you guys want to download this demo yourself and try it out with your graphics cards and stuff, or your RTX cards, or hell, try it with Pascal or whatever and see what happens. I'll put a link to it down in the description below. You can get it on Steam. There is a standalone, which we're going to be running right here. So we're going to go ahead and fire this up, and we are going to take a look at the menu settings and what the different options and stuff are. Okay, so here's the menu right here. We go to options, we get various things, environment setup. Oh wow, okay, sky type, original environment map, Earth. Let's go Earth. So you can change settings in the game. And every time you do that, it has to reload the game. Oh, check this out. Okay, so you can go in and change things like the sky, the lighting. So we have a hole in the sky right here, but you can see there's no lighting or anything shining on the wall because we have a skylight here, but you can see where some of the light is kind of bleeding and wrapping around the edge. Now if we go in here and change that environment, oh, there we go. So there's the God rays and stuff that we're kind of used to. So what's happening here is this scene is being entirely rendered by this light source. So the light's coming in and it's bouncing and refracting on these different textures and surfaces. You can see now as we shoot, we get a light path that sort of follows. So now you can see that we're inside here. The sun is no longer applying any sort of light to this space because we've moved around from where the light is. But as you can see, there's a little bit of sun glow here in the corner because there's still some direct light right there. So I wonder if I can put the sun in position to shine through here. This is cool how you can go in here and just play with the sun position. Oh, it might have been a little far. Imagine if you could really do this in real life, like, with the sun, there.
It makes shooting so much easier.
Yeah, but it would kind of suck for everyone else, wouldn't it?
Well,
that's their problem.
Yeah, they're not shooting. You have to file a permit with Hollywood to move the sun for your shoot.
The problem is I have no reference as to the compass, so I don't know like where the sun is going. Well, I mean, you obviously get the idea, right? Hey, punk. Look at that, we're creating a shadow on the wall. At least the gun is, because I'm just a floating gun in a hand. So because there's light sources right here, I'm creating a shadow on the wall right there. And look how the shadow starts big and soft, and the closer you get to it, boom. So, I mean, you can see we're getting 80 FPS, which is, okay, let's look at it this way. 80 FPS on a $1,200 graphics card. This isn't about the FPS. It's about taking a title that's 22 years old and making it look like this because of applying new logic to it. This is not overlaid on top of the original game. This is the game completely remastered using only ray tracing technology to light this, and not even just light the scene, to render the scene. So we can use my phone as an example. Do you see how the farther away my phone is, because we have multiple light sources. We have one in front of us, we have some behind us, one off to the side, there's a light over here. So you see the shadow is kind of stretching out in all these different directions based on where the light direction is coming from and the intensity of that light source. But the closer I get to the object we're blocking light to, obviously the sharper it gets. So they've mimicked that really well here, as you saw with the gun reflection. Obviously the flag happening right here, so you can see that there is some softness to the flag. My gun should realistically be creating a shadow on this wall. Oh no, it's down there on the ground. So here's an example of that. You can see the shadow of the gun on the ground. When I jump, you can see it sort of softens up because of the fact that I'm becoming farther away from the thing I'm creating a shadow on or casting a shadow. But as I get closer to the wall, you see how crisp that edge becomes? That's something that's not new. That's happened with shaders, obviously, but that had to be faked. That really had to be faked. Where this is truly happening in real time, where the light source is creating that shadow. You see how you can see the texture, like there's depth to it. Like you can tell this is kind of like a corroded steel, like an old warship or something would look like. There's the original game. So, well, the sky's also red because we were using Earth before. So let's go ahead and just, I mean, this is how it looked circa 1997. So let's go back to RTX. There we go. So another thing you can look at here too is the reflections on the ground or in the water. You can see the sun right there because that's the point of which it's bouncing, and we're at the right angle to be able to see it. I think the reflections are a little bit too over-exaggerated, but I think that's also because this is an RTX demo. I think most people know when you go walk around the world and you look, windows and all that sort of stuff, yeah, they're reflective, but my phone screen is reflective, and the problem is they're making everything look like this, even things that are only slightly reflective. Like an example would be this Corsair box right here. Nice product placement, right, Jay? Is this decal on here is shiny. And if I move it around, you can see how it's sort of reflecting the light. But you see how it's not a mirror because it's textured, and sure, it's glossy, but it's not an actual mirror. I feel like in RTX demos, they would turn this into like a glass reflection, like a mirror, because again, over-exaggerating the demo. But that's one of those things where maybe in the future we'll see a dial where we can actually sort of pull back some of those reflections and make it a little bit less exaggerated. But this is just an example of, look how good this looks. This is just an example of how you can take a 22-year-old game with an extremely low polygon count and then make it feel modern by simply applying this to it. What happened? Oh, is he shooting me? Bastard. Look at the way it lights up the scene in there, and look at the way the light interacts with the walls as it goes by. The fact that we're seeing 80 FPS in a game that is being rendered entirely by using ray tracing is a great thing. Now I know that this is going to sound like, well, this is just one big NVIDIA commercial. It's not. What we're looking at here is a technology that is not, it's not NVIDIA specific. This is ray tracing. This is not something that NVIDIA developed. It's something NVIDIA sent out as a goal to bring to mass market basically and do it in real time. I would love for AMD to come out with a driver that would allow us to take their graphics cards and start playing around with real-time ray tracing. They made a statement that they can do it and their graphics cards are great at it simply because of the amount of shaders or the amount of stream processors that they have. I mean, like 4,000 plus stream processors, something they've had for a long time. A very different approach to how graphics are rendered versus NVIDIA. So NVIDIA came out with, obviously its driver allowing you to play around with ray tracing and like Battlefield 5 and stuff with your Pascal graphics cards. I really wish AMD would do the same thing. Now, like I said, I can't test this right now with Pascal because this is an all-in-one unit and it's all I have available to me right now. But I'm kind of curious, if you guys have Pascal graphics cards and you download this, do me a favor, try it out, say what your specs are, and then put down in the comments what your FPS is, if it worked. If you're running another RTX card like 2060, 2070, whatever, then also do the same thing. What is your FPS? Since I wasn't able to actually show you what the other graphics cards are performing like, you can see we're getting 80, 81 FPS right here with a 2080 Ti. And I know that sounds depressing, but this really is just the first phase of the future of games. A lot of people said the same thing about rasterization. Nobody cares about shadows. No one cares about reflections, or, well, I guess screen space reflections. Nobody cares about that sort of stuff. But then eventually it becomes the way things are done, and you don't know any different until something new comes along, and then the public says, we don't care about that, we don't care, and then it becomes the norm, and then it's just a repeating cycle. I guess a good way to put this is, this game came out almost 2 years after Toy Story. Toy Story came out in 1996, but was obviously in production long before that. And it took a very long time to render that video because it was using fully ray traced CGI. And if you go and you look at the way things looked back in 1996 with the original Toy Story, when that first came out, everyone was like, this is so cool, it looks so real. Go and look at it today, and look at how much your mind has adjusted to the way things have evolved. And then watch the Toy Story 4 teaser. And then you'll realize, like, wow, we have definitely come a long way. And doing that for games is not a bad thing. So anyway, as you guys heard me suggest, to put down your specs, how's it running on your system? Put it down in the comments below so people can find out. And then also, like I said, this is entirely free. You can download the demo, you can go and play it, see how it runs on your own systems, and there's nothing wrong with that. Free is a good thing, right? All right, guys, thanks for watching. And as always, we'll see you in the next one. And I am still gonna do that. How does DXR run on non-RTX cards? We just kind of got caught up with this whole studio move. So thanks for sticking around while the content's kind of sucked lately.